In this video, we're going to learn about the common ion effect, which is that when a solution contains multiple solutes that have a common ion, the solute's solubility will decrease. So for example, lithium carbonate is slightly soluble in water. 15.4 grams of lithium carbonate dissolve in a liter of solution at 25 degrees Celsius. However, if you were to try to dissolve lithium carbonate in a solution of lithium chloride, the solubility will be significantly less. So in a 1.00 molar solution of lithium chloride, lithium carbonate, which has that same common ion of lithium in it, will have a substantially lesser solubility, and that's something that we're going to calculate. So I'll just point out that the KSP for lithium carbonate at 25 degrees Celsius is 2.5 times 10 to the negative second. So what we can do is we can make an ice chart. And what we find is that the initial concentration of lithium ions in a 1.00 molar solution of lithium chloride is 1.00 molar. The initial concentration of carbonate, of course, is nothing. And so as the lithium carbonate is added, we know that the concentration of lithium ions will increase by, let's say, 2x for every x that the carbonate increases by. And so at equilibrium, the concentration of lithium will be 1.00 plus x molar, and the concentration of carbonate will be x molar. But since the lithium carbonate is only slightly soluble, remember, it has not a particularly great solubility in normal circumstances, and it's going to be even lesser given the concentration of lithium ion starts out pretty high. So what we can do is we can say that 1.00 plus x for the lithium concentration is pretty close to just 1.00 molar. And that's going to make the calculation just a little bit easier for us while not sacrificing too much in terms of accuracy. So from here, KSP is equal to the concentration of lithium ions squared times the concentration of carbonate ions. And we have 2.5 times 10 to the negative second is the KSP. We've set that equal to the 1.00 molar lithium ions squared times an unknown x. And we find that x is simply 2.5 times 10 to the negative second molar. Convenient mathematics here. And what this means is this is the solubility of lithium carbonate. This is the concentration of lithium carbonate at equilibrium, which is the point of saturation. And I'll just point out here that because of the stoichiometry, one lithium carbonate forms, actually it's two lithium cations and one lithium carbonate. Because X is our concentration of carbonate, and that's a 1 coefficient here. And we also have a 1 as the coefficient of the lithium carbonate. We can say that not only is X equal to the carbonate concentration, it's also equal to the concentration of dissolved lithium carbonate. So the next thing that we'll have to do is we'll have to use the molar mass of lithium carbonate, which we can calculate out to be 73.89 grams per mole. And we can take the concentration of lithium carbonate in a saturated solution and multiply it by the molar mass. And what we finally get is the fact that in this particular solution, lithium carbonate is soluble to the tune of 1.8 grams per liter. So in conclusion, what we know is that lithium carbonate is somewhat soluble in water at 25 degrees Celsius. It has a solubility of 15.4 grams per liter. But lithium carbonate, in the presence of a molar concentration of lithium ions, well, in that case, lithium carbonate is drastically less soluble. It is only 1.8 grams per liter is its solubility in a 1.00 molar concentration of lithium ions, as you would have in a 1.00 molar solution of lithium chloride. So I hope this video has helped. Feel free to leave any questions or comments in the comments section below. Thanks for watching.